Hello, I'm here today to talk about how real-time emissions monitoring can be used not only to meet, but exceed environmental reporting requirements. Specifically, I'm going to focus on sustainability reporting and carbon monitoring, which is an area of increased focus today. My name is Philip Black. I'm the Global Emerging Solutions Lead at Wood. I have over 20 years of experience in a variety of roles, including systems integration, equipment monitoring, software development, and product management. I graduated from the University of Kansas with a degree in chemical engineering, and I'm a licensed professional engineer in the state of Texas. I've published my LinkedIn address as well. I encourage you to connect with me and continue this discussion online. If we consider the value of carbon in terms of increasing need for regulatory compliance, the fiscal cost defined by emissions trading, and growing stakeholder and customer pressure for reporting, then the value of carbon is increasing. In 1997, there were around 60 climate change laws worldwide. Now there are over 1,200. According to the Grantham Research Institute on Climate Change, the future challenge lies in strengthening existing laws and filling gaps, rather than devising complete new regulatory frameworks. Importantly, most, but not all, countries have the legal basis required for climate change on which further action can build. Since the EU ratification of the Paris Agreement, the price of carbon within the EU emissions trading scheme has risen six-fold, illustrating the clear influence of environmental policy. As governments continue to commit to significant reductions in emissions, I expect this policy influence to continue. Now that the US has signaled it will rejoin the agreement as well, it will be interesting to see what policy changes occur here as well. In the US, even though we don't have a carbon tax or a national trading scheme, the government is supposed to use a value known as the social cost of carbon to evaluate policy decisions. A simple explanation of SCC is the amount we should be willing to pay to avoid future damages. In 2016, the social cost of carbon used by the US government was estimated to be around $53 per ton. In 2020, however, New York set the cost it would use to $125 per ton. The US is updating the national value as well, which is expected to rise significantly. However, irrespective of governments, I believe that the true value of carbon is at the corporate level. The last 5 years have seen a major increase in voluntary reporting protocols from institutions, with many companies now publicly stating their climate goals. In fact, there are over 200 frameworks to choose from when reporting. 5 are the most common. Now, the challenge is consolidating them and creating a standardized approach from which comparisons can be made. The Big Four accounting companies are actively working to develop a more unified standard that can be used as a basis for financial audits. At Wood, we have publicly committed to reducing our carbon emissions, setting a science-based target to reduce our direct, or Scope 1, and indirect, or Scope 2, emissions by 40% in 2030, putting us on a trajectory beyond the 2 degrees Celsius temperature goal identified by the Paris Agreement. These public statements are not only a direct response to shareholder interest, but are also a response to pressure from other groups, such as consumers. We have recently been engaged by a global manufacturer to help them report their carbon emissions as a result of pressure from one of their distributors, a major supermarket chain. Consumer sentiment is changing as well. In one survey, 88% of respondents across the US and UK said they value brands that are more environmentally friendly. Enough so, in fact, they value to pay a premium for those products which are manufactured and transported in a more sustainable manner. Companies are coming under pressure from consumers to show real progress towards environmental goals for both greenhouse gas emissions and air emissions in general that go above and beyond what is legally required. Whether considered by each of these or as a whole, the message is clear. The value of carbon is increasing. Is this a real shift, or is it simply another attempt by corporations to generate media attention and foster consumer goodwill? I believe it's a real shift. There is increasing pressure by investors for companies to focus on sustainability. Investment firms and individual investors have made commitments to put their money only into companies that are deemed as having safe climate change risk. At the beginning of 2020, Larry Fink of BlackRock announced that climate change would be a central part of BlackRock's investment strategy, stating that climate risk is investment risk. He strengthened his message at the beginning of the year by saying he believes the pandemic has created such a crisis that it forces us to confront climate change and consider how it will alter our lives. This is a clear message of a continued focus of investment managers. In Larry's own words, no issue ranks higher than climate change on our clients' list of priorities. They ask us about it nearly every day. We are seeing the rise of traditional investing companies creating specific funds which use ESG, environmental, social, and corporate governance, as a criteria for inclusion in the fund, with a blanket ban on companies in some industries having what is seen as significant ESG risk. Vanguard reports that for investors in the US, there are more than 600 ESG funds and ETFs available, representing $161 billion in assets under management. BlackRock reports similar figures as well. The refocusing of investors to include more than just a pure dollar returns mindset means that companies need to be aware of both their rating and the overall ESG rating of their industry. Mainstream names such as Bloomberg, Reuters, and the Dow Jones all publish ESG rankings and risks. Some use only publicly available data, others exclude self-reported data, and even some others claim to use machine learning to assess private companies who don't report at all. Anyway, the message is clear. Investors and investment agencies are demanding and paying for this information. These 3 points signal a true shift is occurring and it needs to be taken seriously. Let's talk now about how reporting is normally done. Right now, the de facto standard is a report at a corporate level which has limited details for specific sites or facilities. It's prepared annually and shows one total value for the year. The main focus is on things the company did last year. Somewhere buried in the text is a statement indicating which framework the company is using. At Wood, we're currently using the Global Reporting Initiative, or GRI, as our basis. There's a lot of material in these reports, but they almost always contain information on a company's carbon footprint. This means that environmental departments are very involved in providing this material for inclusion. So, let's talk about the perspective from which regulatory compliance departments, such as HSE, collect data. When gathering data for regulatory reporting on compliance-driven activity, more data is viewed by many legal departments as a potential liability. The focus is on gathering only the data that is absolutely needed and on keeping that data for only as long as the regulations require. In terms of operating permits, investigation and follow-up action take place after a limit has been exceeded. A lot of the carbon reporting data in the US is to comply with EPA's greenhouse gas mandatory reporting rule, or other regional or state reporting programs like the one that exists in California. This is an annual report which is broadly focused across sectors and takes a very prescriptive approach, down to the specific set of formulas which must be used. For the energy sector, there is a lot of process information that has to be used, which usually means dumping the information from Pi into Excel, such as shown on the screen, in order to calculate totals. While the EPA's rule provides good information, there are gaps in coverage, which means that it can't be the entire basis for a climate change report. Additional information is gathered using a top-down, high-level approach, which usually means more spreadsheets. This means you end up with a lot of spreadsheets floating around during reporting season. This approach has to be adjusted as the information comes under greater scrutiny by investors and consumers. Companies who want to lead the market in sustainability can't rely on spreadsheets, post-it notes, and emails to generate their reports. For the information to be useful, the entire mindset has to change from a traditional compliance view towards a new guidance view. This guidance mindset means gathering as much data as possible, keeping it as long as necessary to understand developing trends, either good or bad. There needs to be a change in focus from reporting deviation towards reporting excellence, which means understanding what is going on before problems occur and having the ability to react. It will be necessary to detect near misses in order to understand good behaviors, which can be turned into best practices. Visual presentation matters, which means the information is not just printed into the format the state requires and mailed off, but it has to be integrated into whatever business intelligence platform is used. It must be tailored for different audiences. Information for management will by necessity be less detailed, but it must be related to financial performance or any metrics they are directly accountable for, because that's what they pay the most attention to. Information for specific departments should be focused as well. They must have information they can act on. Even operators should be able to see the carbon impact of their decisions, ideally within the same environment they use on a day-to-day basis, which could mean a DCS or historian. Consistent, accurate information has to be accessible to everyone. It needs to be possible to see what the uncertainty is of any value on the display. It should be possible to understand and detail the entire calculation process to ensure transparency and easy verification. Only by doing these things will a true shift occur. Let's talk about the increased cost of reduction efforts. The bar chart on this slide is a marginal abatement cost curve with carbon abatement projects identified as separate bars and ranked by cost, with the volume of abatement achieved by each option indicated by the width of the bar and the height indicating the cost. When the options for reducing carbon emissions are assessed in a holistic manner such as this, there are usually some very easy first steps to make, such as new energy efficiency programs, which may actually reduce operational cost or represent only a marginal increase in cost. As further reductions are required, costs increase and informed decision-making becomes more important. It quickly becomes a harder sell to make investments in projects costing more, but which can result in more significant gains. This is where real-time carbon footprinting capability adds value. It can aid in operations, business strategy, and even in capital project investment decision-making. So, how does it work? The first step is to define the scope or boundaries of your carbon footprint and identify the data needed to calculate the emissions. A physical survey may be done in conjunction with this step. This is used to create a model which will inform the installation of any hardware and design of any systems necessary. After the calculations are implemented and the system is operational, the platform must be deeply integrated with other business processes by tying into the various data streams. Targeted reports and dashboards are also developed as required. At this point, real-time insight becomes enabled, providing high-quality, verifiable data. The next step is to start using the data in optimizing operations and in developing an investment strategy based on a more accurate cost-benefit analysis. Then, this strategy will guide in the design and delivery of new projects or upgrades in order to make step change reductions in emissions. Taking these steps is where decarbonization can be realized. Real-time carbon footprinting continues to add value by measuring progress on the path towards carbon net zero. These are the tools to know where you are and track your progress towards where you want to be. Pay attention to the processes I've listed above the graph. Next, I'm going to talk about 3 cases of companies along this progression and the improvements they realized by going through the process. Environmental teams are seen as cost centers, not value creation centers. The focus is always on reducing expenses. In this first instance, a carbon footprint project spearheaded by the environmental team actually created something of value and benefit for the entire company. I was part of the wood team that worked with an upstream gas producer with over 9,000 well sites. Their goal was simple, just to meet the greenhouse gas reporting requirements for the EPA. This was back when the program was first rolled out. We covered the first 3 parts of the process presented in the previous slide: scoping, data survey, and model creation. Our goal was to develop an emission model that met the reporting requirements and kept them in compliance. The scoping and model creation were fairly straightforward. The EPA had designated the scope of the reporting as well as the specific calculation model and methodology used. The real challenge came during the data survey. After reviewing the scope and information required for the calculation model for all the facilities involved, it quickly became clear that this would be a substantial effort. As it ended up, there were over 1.2 million data points required for doing the reporting. Anyway, much of this information was tracked by separate functional groups for different purposes, in different formats, and in completely different systems. Databases, spreadsheets, handwritten notes, which complicated its collection, aggregation, and dissemination. After looking at these sources, it became clear that the information contained in the systems was inconsistent. One system would show a well with an inactive status, while another showed production numbers for that same time period. It was during this discovery phase that we had to make a decision on how to manage inconsistencies. Since we had no ability to update the original sources of the data, we created what we called the Greenhouse Gas Common Global Model, imported the data from those systems, and reconciled the information within this system. We created a tool which would scan the records and identify these inconsistencies. This allowed us to ask the site to identify the most accurate data. So then we could make corrections in our system. We could also notify the system owner about the discrepancies and help them in their reconciliation efforts. The reporting was tedious and laborious the first year, but we got it done. However, something really interesting occurred once the model was deployed and the results from the first year were generated. It quickly became clear that this was the best set of data for all their wells within the entire organization. We started getting requests for access to the database, which housed the common model from different groups. The analytics group requested access to the information because it was easier to pull. It was stored in a single database, and it was more accurate due to the automated business logic created to detect and then resolve inconsistencies. This model served as the foundation for the corporate team to better evaluate optimization opportunities. While not every inconsistency got resolved in the source systems, there has been a noticeable improvement in the accuracy of the information. The process continues to be used today, more than 10 years after its deployment, a testament to the lasting value it has created. As I mentioned, there is value in gathering more data at increasingly detailed levels, making a change from compliance to excellence reporting. Just looking at annual greenhouse gas emissions by site may reveal that one site is emitting more than others, but it doesn't provide insight as to why. Perhaps the site is larger or has more pieces of equipment. Looking at emissions by piece of equipment per site can reveal what specific process is contributing to the majority of emissions. To get even more specific, looking at emissions by time of day can reveal additional information, such as certain units operate less efficiency under certain conditions, such as extreme temperatures or during different operating shifts. With detailed monitoring, it's possible to start comparing equipment by type to see when one is doing worse than the others. One of our clients needed to improve progress reporting to support their stated goal of harnessing technology for a 30% reduction in emission intensity by 2030. The facility we worked with, a refinery, reported under the US EPA's program. Regulatory reporting required an annual total, but management wanted deeper insight. Their annual carbon emissions were calculated in spreadsheets, which wasn't ideal, but worked since it only had to be done once a year. To get deeper insight, it would be necessary to create a new tracking method which could generate totals daily, something not possible to do with a spreadsheet. They didn't want a new system to learn, they wanted to integrate a solution within their existing air emission monitoring system. We worked with their team to develop a new approach to tracking information, an approach which more closely matched how they report and manage other air emissions at the facility. The first challenge was to figure out what the scope of our monitoring would be. Since they were a refinery, a majority of their direct emissions came from their process units. We decided to focus on those units since the information was easily pulled from their historian. The next challenge was to determine a calculation basis. Corporate reporting allowed each facility to use, as much as possible, the same information they reported to their EPA in their corporate sustainability report. We decided the system would only focus on the scope covered within the EPA guidelines and by using the same methodology prescribed. Early on, the decision was made not to try for exact parity with the EPA report, but enough to get insight so they could do a comparison of carbon emissions for each type of unit. This allowed for reasonable assumptions and simplifications to be developed. The calculations were created for the normal variety of process units a refinery has: loading racks, boilers, heaters, sulfur recovery units, flares, cat crackers, etc. It was challenging at times to adapt the annual reporting framework to a daily basis. Many of the factors had to be adjusted since the time period was embedded within them. Other equations used counts of specific activities that occurred, which weren't possible to determine using only information in the historian tags. For these cases, we looked at previous data and developed some reasonable assumptions that could be adjusted manually if necessary. If there was a significant change in the activity count, adjustments could be made retroactively and the system would automatically update everything which depended on that changed value. The final challenge was how to present the information. It had to be possible for management to look at totals across all the units as well as a normalized comparison of similar types of units in different parts of the plant. For example, the 2 cat crackers. The system needed to highlight when performance varied unexpectedly. We developed dashboards with drill down capabilities and some alerts that monitored for unexpected change. So, what about the results? After rolling out the program, and establishing confidence in the results, the plant manager now receives alerts on sudden changes or when projections meeting their annual target are at risk. The attention by management was cause for some initial consternation, but the result has been positive with management more engaged. There have been some new initiatives created to increase the quality of data coming from the instrumentation. We're looking at expanding and using some of the advanced tools Microsoft is developing to make even better predictions using machine learning models. This is a good example of what it takes to move from a regulatory towards a guidance mindset. In England and Wales, the Water Services Regulation Authority oversees water treatment plants. They set limits on charges, taking into account capital investment schemes and expected operational efficiency gains, similar to how public utilities are regulated here. Every 5 years, a review takes place. Part of that review is development of an annual carbon budget, expressed in pounds sterling. Unit carbon costs are assigned for a specific list of activities which count towards this annual budget. Certain activities, like exporting renewable energy, have a negative price for an added incentive to offset the investment cost. Carbon costs can be considered for capital investment decisions, which means the possibility of additional money for projects which lower the carbon footprint. Water UK, their industry association, has also publicly committed to achieve net zero emissions by 2030, further increasing pressure to more accurately monitor carbon footprinting. A public utility in England decided to pilot a carbon monitoring solution to assess the value it could bring to them. The goal was to see if information from multiple systems could be integrated in such a way as to provide detailed insight into their site footprint at the hourly level. They wanted to know how each area of operation and each individual piece of equipment contributed to their yearly total. I worked with them to create a model using the methodology defined by the UK Water Industry Research Group. We went through the methodology and identified the most accessible sources of information for each parameter at the site. There were a wide variety of sources. We used information from the SCADA system, accounting system, fleet management system, and even invoices themselves. After calculating raw carbon emissions, we converted each of the emissions into a financial cost using their latest negotiated price of carbon with the regulator. The result was inspiring. This Fitbit for carbon, as we termed it, generated conversations between the operations, engineering, and management team that had never before been possible. The carbon footprint of each chemical is integrated into the purchase price, giving planners a more comprehensive basis for determining the best mix of agents to deliver safe drinking water. Overlaying the information in the monitoring system with maintenance records allowed the comparison of the carbon cost of routine versus unexpected maintenance. In one case, we saw a spike in energy usage even though the dosing rate was consistent. Upon further investigation, we discovered there were 2 pumps that could be used. One of the pumps was significantly less efficient than the other. You could see the step change when it was put into service. Operators had felt like this pump wasn't working as well, but they didn't have a numerical basis to justify replacing it. This information generated a more comprehensive business case for investment in equipment. Now that this data is available, predictive models can be developed for long-term planning and decision-making. Once the system is deployed across multiple sites, emission intensity and normalized carbon cost can be directly compared for all facilities. This will drive further improvements. I showed this slide earlier, but I want to show it again. These 3 cases I've talked about make a compelling argument for fundamentally changing reporting and the steps necessary for it to happen. This is where companies are today, manually preparing reports and selecting reduction measures that are cost savings. This is where clients need to be soon, having robust data to support significant investment decisions to achieve their carbon goals. Thank you for your time. I'm happy to take any questions or comments you may have.